Hello everyone, we're the Data Magician Group and here is the list of our group members and today's presentation is about financial illiquidity and the presentation will be divided into 6 parts. First is the project background. Our topic is related to the global economy and stock market performance in 2009 after the financial crisis, and we will analyze the relationship between different influence factors including return volatility and trading volume in a special economy recovery period using correlation, regression, and clustering analysis. The main issues we focus on is the stock market illiquidity. The analysis will help us to know more about the risk and the trends of equity markets. In our dataset, there are 11 variables including different dimensions of the stock performance, from trading volume, bid-ask spread to illiquidity and market capitalization. Our topic focuses on the factors which may affect illiquidity in the stock market. However, illiquidity is very abstract. Many indicators can measure the illiquidity in the stock market, and our work is to find out the obvious indicators that investors need to consider in actual transactions. Therefore, we choose bid-ask spread and army-hold illiquidities as DVs, and the others as IVs to do more accurate analysis. All in all, we try to find out the quantitative relationships between illiquidity and the correlation factors in the next several sections. And now is my partner to introduce part 2.
Talking about descriptive statistics, first we look at the histogram of 5 original variables. Only vola is normal distribution. The other 4 just have a decreasing trend but don't coincide with normal distribution. Therefore, for the later regression analysis, we need to transform these 4 variables into normal ones. So, we generate 4 log variables which are normal distribution. In order to test the best performing regression, we need to select the most suitable DVs and IVs according to correlation analysis. As you can see in the first correlation matrix, BS100 has stronger correlation with IVs than ARMY100, so perhaps BS100 is the better DV in the regression. As for the IVs, if the correlation coefficient absolute value is larger than 0.5, we'd better not put these IVs in one regression to avoid multi-collinearity. Therefore, VP and P, VP and market cap, these 2 pairs are now supposed to be in the same regression. Next, let's welcome my partner to illustrate the regression analysis part.
So how will these variables influence the market illiquidity? We firstly use BS100 as our dependent variable in this regression model. In the beginning, we put every IV into our model and found there is serious multicollinearity, so we tried to use automatic step regression by SPSS in step 2, but the multicollinearity still happened. Then we decided to manually run the step regression. From the result, we found market capitalization and VP should not be together because of the multicollinearity. They are correlated, so the market cap might represent VP in some way. And we try to discover the optimal regression models based on the 3 rules we set. First one is there should not be any multicollinearity, and the second one is the result should be significant. The final one is that the result should make sense in common sense and in real life. After that, we found 2 optimal models. As you can see in the table, the R squared in the first model is 0.4246, and the R squared in the second model is 0.4248, which are both acceptable. And we have these conclusions. The stock volatility will have large positive impact on market illiquidity, which is called BS100 in this model. However, the turnover rate, the trading volume, and the market capitalization have certain negative impact on its illiquidity, but the impact is small. Finally, the closing price doesn't have any significant impact on illiquidity, so we shouldn't consider that when we decide which stock we should buy. And what if we change BS100 into Army 100? Let's see.
Here comes to the regression analysis of Army 100, and we still included all independent variables and did the step regression. And we found that the optimal regression model for Army 100 is the step 02 model because there is no serious multicollinearity and all independent variables are significant. And for the results, we could see vola and log p have positive impacts on this dependent variable, and log turnover rate and log market cap have negative impacts. The impacts of log turnover rate, log p, and log market cap are little compared to vola. And here come to the comparison between BS100 and Army 100 optimal models. Vola and log turnover rate, log market cap are significant in both BS100 and Army 100 best models, and log VP should also be looked at in the spread measure, and log P should be looked at in the Army Hood illiquidity measure, and BS100 might be a better dependent variable than Army 100 because whose value of R-squared is much larger than that of Army 100. And next would come my partner to introduce the regression analysis by adding a dummy variable.
In this section, we will add the dummy variable fin to investigate whether financial stocks were more in liquidity than non-financial stocks during April 2009. First, we apply the optimal model of BS100. We can see in the both regression 3 and 6, there is no multicollinearity, but the dummy variable is not significant. So next, we decided to run the step regression, and we found regression 7, 8, and 9. Finally, we will choose regression 9 to be the optimal model of BS100 because all the variables in the model are significant and the R-squared is acceptable. Based on the above regression results, we would try to add fin to the optimal models of Army 100, and you can see that although there is no multicollinearity, the dummy variable is not significant. So we will still do the step regressions. Finally, we find the following 3 regressions, and we will choose regression 6 to be the optimal regression of Army 100 because it has the highest R-squared and has no multicollinearity. To find out what is the best model with the dummy variable, we compare the above optimal regressions. We will see that the R-square of BS100 best models is higher than that of Army 100. Besides, all the variables in BS100 is significant, so BS100 might be a better dependent variable. According to the above regression, we can conclude that the financial stocks are more illiquid than the non-financial stocks in April 2009. Next, we add the 3 interaction variables in regression 9. All new added variables are significant. We can see that the volatility of financial stocks has a higher impact on the bid-ask spread, and so the relationship between illiquidity and the volatility is stronger in the financial market. Accordingly, log P and log turnover rate of financial stocks has a little impact on the illiquidity. Next, let's welcome my partner to introduce the cluster analysis.
So in this section, we will use K-means cluster analysis to test the consistency of our previous conclusions for another point. Firstly, we will choose market cap, return, and volatility as our clustering variables. After comparing the different candidates of clustering solutions, we found that the cluster number of 4 is the best. From the ANOVA table, we can see that the p-values of the clustering variables are all significant, and we also have compared the results of the hierarchical clustering seeds with randomly generated seeds. It can be seen that the agreement is high as 89%. Next, we try to validate our clustering solutions. We choose to use BS100 as our additional outcome measure. For the ANOVA table and means plots, we can see that the result is good. And we have also tried discriminant analysis. The results show that over 94% of original cases are correctly classified, which is still good. The picture on the right side also shows that our dataset has been successfully classified as 4 parts. Finally, we'll profile our clustering solutions with an additional variable, which is gigs. We try to use data visualization to make our findings more clear, and if we look at a table on the right side, we can know that these four groups have significant difference. To be more specific, for example, Group 1 has the second lowest market cap, second highest volatility, second highest illiquidity, and the highest ratio of heavy financial companies. But Group 2 has the second highest market cap, second lowest volatility, and second lowest illiquidity. Then we can draw the conclusions that there is a negative relationship between market cap and illiquidity, and a positive relationship between volatility and illiquidity. The financial companies are more likely to suffer relatively high illiquidity, and these findings are consistent with our previous conclusions.
We have done correlation, regression, and cluster analysis. As you can see, we have provided results about independent variables who have significant impact on illiquidity-dependent variables, and how much these impacts would be. Like vola always have the highest impacts. Turnover rate and market capitalization have significant negative impacts on both DVs. And there is a significant relationship between the financial stocks and the illiquidity. And we also suggest investors to use BIS 100 as the dependent variables when doing illiquidity analysis, and to be aware that financial stocks are thought as more illiquid than stocks of other industrials. Thank you.